2.7. You ready to use some string methods? Here we go. For our first concept, we'll be talking about the Java API, our learning objective for string class, create string objects, call string methods. Have you ever tried to tell the computer to do something for you and it just wouldn't do it? And it's not because the computer doesn't know how to do that thing. The computer can do so many amazing things. You just need to know the right way to ask the computer to do that. So that means you need to turn to the instruction manual to figure out how to communicate with the computer. Java has its own instruction manual called the Java API, and it lists all of the classes that Java comes installed with. And it details all of their instance variables and methods that you can use as well. Now, you might be asking yourself what the Java API is. API is an abbreviation for Application Programming Interface. It's the documentation of all the packages, classes, and interfaces that are included with a programming language. That means it lists all of the instance variables, the constructors, and the methods. So, an API contains packages, a package contains classes, and classes contain variables, constructors, and methods. The classes that are included in the Java API are meant to make it easier to do complex coding tasks. This aligns with our essential knowledge. Application program interfaces and libraries simplify complex programming tasks, and classes in the APIs and libraries are grouped into packages. So you can think of a package like a gift or a box that you receive in the mail, and then you open it up and you're like, oh, there's a bunch of Java classes in here that will make programming easier for me. Yes, this API sounds great, and we need to know where to find it. You can find it at its directed link, https://docs.oracle.com/java se/8/docs/API/. Yeah, that is really confusing to memorize. So just Google Java API. It will take you right to it. There is one package in particular that we will be looking at that is the java.lang package. If you look through the list of these classes, you're going to recognize some of these words in here. The classes that we are going to pay particular attention to are the integer class, the math class, the string class, and the system class. Now, we've had exposure to all of these classes already. We are just going to be looking at them in further detail. So the java.lang package is included in all programs by default. So even though Java has access to all of these classes, it doesn't include all of them in every single program that you write. You need to tell your Java program which package you want to include, except for this java.lang package. It's included in every program that you write. This aligns with our essential knowledge. Documentation for APIs and libraries are essential to understanding the attributes and behaviors of an object of a class. So we're going to start off by looking at one class in particular, and that is the string class. If you look up the string class in the Java API, it will give you information about that class. It will tell you about the constructors that you can use, and it will tell you about all of the methods that you can call for that class as well. This aligns with our essential knowledge. The string class is part of the Java lang package. Classes in the Java lang package are available by default. We're going to be pulling some methods out of that string class and looking at them one by one. First, we're going to look at the length method. Still the same learning objective for string class, create string objects, call string methods. When you look up a method in the Java API, it will show it to you in two parts. It'll be a summary, which will look like the signature of that method and give you a very brief description. If you click on it, it will link down to an area where you can get further detail about that method. So both of these boxes are giving us information about the length method. It looks like it has a return type of int, so it is a non-void method. Its name is length, and it does not have any parameters in the parentheses, so it is a non-void method with no parameters. It tells us that it's going to return the length of the string that calls this method. Yep, the API takes care of all of our signatures for us. In these statements, we can see examples of calling that length method. Starting off, we are calling that length method on a string literal. A string literal is an object, so we can call a method on that object by using our dot operator and saying the method that we want to call. So if we called the length method on hello world, and again, I'm using an underscore to represent a space just so we can see it. A space is a countable character. That's going to evaluate to 12. So starting with the H, counting all the way through, including the space and the exclamation mark. 1, 2, 3, 4, 5. The space is at 6, 7, 8, 9, 10, 11. The exclamation mark's at 12. So this statement will evaluate to the integer 12, just like we saw that the length is a non-void method and will return an integer. Our next example is still a string literal, but we have an escape sequence in there. Count that up and see how many characters you think are in that string and see what this method will evaluate to. This method also evaluates to 12. Batman is 6 characters. Now, I know there are 2 characters in the string literal for the tab space, but that escape sequence turns into a single tab character, and that tab character counts for 1 in the length. That brings us up to 7, and then Robin is our last 5 to get us up to 12. Our next example, we are making a string object called empty, and we are setting it to the empty string, open quote, and then immediately followed by a close quote. There's no space in there. Now we can call methods on string objects as well. We don't just need to call methods on string literals. So our object name is empty, and we say empty.length. Go ahead and shout out what you think that will evaluate to. I heard most of you shouting 0. That is correct. There are no characters in there. That will evaluate to the integer of 0. In our last example, we are declaring and initializing 2 strings, fname and lname. We are calling the .length method on both of them. Both of them individually will evaluate to integers, and then we can include that in expressions, which means that we can use that plus sign in between there. Now, will that plus sign act as the addition operator, or will that plus sign act as the concatenation operator? Remembering our precedence table, the dot operator has a higher precedence. These methods will evaluate to numbers first, which means that plus sign will be the addition operator, and we will add the 2 integers that we get back from each of these methods. So Peter will evaluate to 5, and Parker.length will evaluate to 6. 5 plus 6 evaluates to 11. With a non-void method, we would likely want to catch that result into a variable or pass it in to another expression or method call. Make a note that string methods can be called on string literals or string variables. This aligns with our essential knowledge. The following string methods and constructors, including what they do and when they are used, are part of the Java quick reference. Int length returns the number of characters in a string object. The next method that we will be looking at is the substring method. Same learning objective for string class, create string objects, call string methods. So if we see a string like hello world, we would know that that has a length of 12. Hello is 5 of those characters, the space is 6, world is another 5 characters, bringing us up to 11, and the exclamation mark would be our 12th character. If we ask that string its length, it would report back a 12. Each of the characters has a position number as well, known as an index number. The index positions start at 0, so this string has indices from 0 to 11. What you are doing, you are telling the computer how many spaces to move from the beginning of the string to find the character you are looking for. So if you tell the computer to go to the beginning of the string and move 0 spaces, you will find the H there. If you go to the beginning of the string and you tell the computer to move over 2 spaces, whoop whoop, you're going to be pointing at the first L. To get a better example of that, let's look at this table. Let's say we have the string Han Solo. If we called the length method, that would report an 8. 3 characters in Han, one more for the space, that gets us up to 4. Solos an additional 4, that's 8 characters. If we wanted to find out the last index is going to be 7. The first index is 0, and then we count all the way up. That second O would be at index 7. If we set our string to Chewbacca and we called the length method on that, that would evaluate to a 9. The last index then would be at 8. Our indices would be from 0 to 8. Finally, with Millennium Falcon, the length method would evaluate to 17, which means our last index would be at 16. The first index is always 0. The last index is always the length minus 1. This aligns with our essential knowledge. A string object has index values from 0 to length minus 1. Attempting to access indices outside this range will result in an index out of bounds exception. Having an understanding of the indices, we can now use this substring method. Looking at its definition from the Java API, we can see that it is a non-void method. It is going to return a string. The name of the method is substring, and we have to supply 2 parameters: the index of where we want to begin and the index of where we want to end. It tells us that it will return a new string that is a substring of the string that's calling the method. The substring begins at the specified begin index and extends to the character at index and index minus 1. This aligns with our essential knowledge. String.substring int from int2 returns the substring beginning at index from and ending at index 2 minus 1. Here's an example of a string. We have the string hamburger. We have our index numbers listed underneath it. We have a statement where we have that string literal hamburger, and then we are calling the substring method with the parameter list 4, 8. The 4 is inclusive, which means we will start taking characters at this location. The 8 is exclusive, which means it will not be included. That means we will stop taking characters at the 8, which means this statement will evaluate to the string urge. Another example, we have the string smiles with the index numbers listed underneath them. We have a code sample where we have the string literal smiles. We are calling the substring method. We are passing in the actual parameters 1 and 5. 1 is where we begin, so we will include the character at 1. We go up to, but we do not include the character at 5. We stop at 5. That statement will evaluate to the string literal mile. If we make a slight change to this and change our actual parameters from 1 to 5 to 1 and 6, what do you think this statement will evaluate to? We know we begin at the 1. Our second parameter is the 6. Now that is exclusive, which means we will stop here right after the 5 because 6 would be the next one. The statement will evaluate to miles. Even though 6 is not one of our indices, this does not cause an error. We have another slight change to that statement. Now, instead of using the actual parameters of 1 and 6, we are using the actual parameters of 1 and 7. What will this statement evaluate to? Again, we are beginning at the 1. This time we are ending at the 7. The 7 is out here somewhere, and that is beyond the bounds of where our string is in memory. That will evaluate to an index out of bounds exception. An index out of bounds exception is an error that happens when code accesses an element in an array that doesn't exist. That means this spot in memory does not belong to this string. It belongs to something else. It might belong to another piece of data that we put in memory. It might belong to another piece of data that a different program put into memory, or it might just be a spot in memory that nobody is using. Either way, we cannot access it with this string. Here are some additional substring method calls. On our first example, we are calling it on the string literal hello world. We are calling the substring from 1 to 2. With our indices, h is at 0, e is at 1. That means this will evaluate to just that e. We will start at 1, and then we will go to but not include 2. For the next one, we are putting the string literal Peter into the variable f name. We are calling substring on the variable f name. We are passing in the actual parameters 3 and 4. That's going to evaluate to an e. The e is at index 3. The r is at index 4. We start at the 3, go up to but not include the 4. For our third example, we have a string literal Parker. We are assigning that to the variable L name. We are calling substring on that variable with the actual parameters 4 and 5. That's going to get us that E in Parker. This aligns with our essential knowledge. A string identical to the single element substring at position index can be created by calling substring index and index plus 1. Which means if you ever see a substring call where the second parameter is just one higher than the first parameter, that means you are just grabbing a single letter. Calling substring on a string does not change the actual string. So if I have a string fname and I assigned it Peter and I called substring on fname, it doesn't change what is stored in fname. Fname is still Peter, which means I would want to capture that result somewhere. I could capture that result back in fname or a different variable. And in the first example, I am capturing it in a new variable named nickname. The other thing that you can do when you call substring, you can pass that along to another method. You can pass that along to a print method or any method that will accept a string. Remember, in memory, strings are immutable. So even if we do set this back to the original string variable, we are not changing what is already in the string pool. We are adding something new into our string pool. The substring method is an overloaded method, which means there is a second way that we can use it. Looking at the Java API, we can call the substring method by passing in one parameter, or we can call the substring method by passing in two parameters. We've been looking at the example of passing in two parameters. Now we're going to be looking at the example where the formal parameter list just has one parameter, that is the beginning index. And that brief example says returns a string that is a substring of this string, which sounds pretty similar to the other use. This aligns with our essential knowledge that there are two substring methods in the string class. Going back to our first example of hamburger, if we have that string literal hamburger and we call substring and we pass in the actual parameter of 4, this is telling us where we want to begin, and that 4 is inclusive. That means we are going to start taking a substring at that 4. We don't have a second parameter telling it where to end, which means it will take characters all the way to the end of the string. This will evaluate to erger. Looking at our other example of smiles, if we call substring on smiles and pass in the actual parameter of 1, that says we're going to start taking characters at 1. We're going to go all the way to the end, which will then evaluate to the string miles. If we change that slightly and passed in the actual parameter of 2, we would start at 2, we'd still go to the end, and we would get aisles. We have a new string up top, emptiness, with our index numbers from 0 to 8. If we have that string literal emptiness, we call the substring method, and we pass in the actual parameter of 9. What string will we get in return? The 9 tells us that we will start taking characters at the 9th location. That means we will go to the end, which is also the 9th location. This will return the empty string. This will not error out. It will not error out until we try to go beyond our bounds, which is 10 or more. Now, we already saw what happens if we try to go above our bounds on our indices. What happens if we pass in a beginning index of -1? -1 is outside of memory on this side, and we want to go all the way to the end. This again will evaluate to an index out of bounds exception. There is memory before our string, and that might not belong to our program. And even if it does belong to our program, it's not something that we are trying to look at right now. Java will not let us do that. Our next method is the indexOf method, same learning objective. If you look up the indexOf method in the Java string class, you will see that it is an overloaded method. All of them have a return type of int. They all have the name index. They each accept a different type of parameter or a different number of parameters. We are only interested in one, which is the one that accepts one string parameter. The definition tells us that this will return the index within this string of the first occurrence of the specified substring. We will be looking for a smaller string inside of a bigger string. We want to know what index it appears at. Some examples: if we have the string literal Robin, we call the method indexOf and we pass in the parameter Rob. We want to know where Rob is in Batman and Robin. That's going to evaluate to 11. 11 is the index of the R in Batman and Robin. Now again, if we use that same string literal, we called the indexOf method and we passed in the string literal of R, that will also evaluate to an 11. It just tells you where that string starts. It doesn't matter that Rob is 3 characters long and R is only 1 character long. It finds the first match and returns the position of where that starts. Our third example, we have Batman and Robin still. This time we are looking for Rob in lowercase letters. This will evaluate to a -1. -1 is this method's way of telling us that it did not find it in that string. You might be looking at Robin and you might say, I see Rob right there, but that Rob is different than the Rob that you are looking for. This method is case sensitive. Looking at the last one, Batman and Robin, what is the index of an? The string literal an. This one will evaluate to 4. That's the an at the end of Batman. It's not the an at the beginning of and. It will find the first occurrence, which is the an at the end of Batman. The indexOf method will always evaluate to an int. That's its return type. Even if it doesn't find it, it will not error out. It will evaluate to the int of -1. This aligns with our essential knowledge that indexOf is a method from the string class. Our next string method is the equals method, same learning objective. The equals method will return a Boolean, meaning that it will return a true or false value. We are going to pass in another object as a parameter to this method, and it will compare the two strings together, and it will let us know if the strings are the same string. If they are, it will return a true. If the strings are different, it will return a false. Looking at some examples, we have the string literal orange calling the equals method, and we are passing in the string literal orange. Both of those string literals are the same. This will evaluate to the Boolean value of true. In our second example, we have the string literal orange calling the equals method, and we are passing in the string literal orange. This time that string literal is all in lowercase. This will evaluate to the Boolean value of false. The equals method is case sensitive. In our third example, we have the string literal orange calling the equals method, passing in the string literal banana that will obviously evaluate to the Boolean value of false. And in our fourth example, we have the string literal orange calling the equals method, and we are passing in the string literal orange with a space at the end. This will evaluate to a false as well because space is a character and it's not in the first one, but it is in the second one, so those are not the same. So I know what you're asking yourself, but what does this look like in computer memory? That's great, let's take a look at it. On the left, we have code sample 1, We are declaring three string variables and we are setting them all equal to the string literal orange. If we looked in memory, there would only be one orange in the string pool. Each of these variables would hold a reference to that same string. Each of these three variables point to the same string in the string pool. Now, what would happen if we called the equals method and compared these to each other? Would those be equal or not? Would that evaluate to true or false? On the right side, we are calling that code sample A. In code sample A, we are declaring three string variables. We are calling the string constructor for each one of those, which means that we will have three different orange strings in the string pool. Each one of these strings will have a different memory address pointing to a different orange in the string pool. What happens if we compare those and see if they are equal? Well, all of these are going to evaluate to true. The equals method checks if the characters are the same. It doesn't check if the memory addresses are the same. It just goes through character by character and sees if all the characters are equal. Our next method is the compareTo method. We are still working on that same learning objective. Let's say you have your two favorite books, The Old Man and ASCII and Lord of the Files. You just read these books and you want to put them back on your bookshelf in alphabetical order. Which book would you put first on the shelf? If you wanted to alphabetize these, you would put the Lord of the Files first, and then you would put the Old Man and ASCII after that. Alphabetically, Lord of the Files comes first. What if you had these two books, A Tale of Two Ints and A Tale of Two Ints? One where all of the words are capitalized and one where all the words are lowercase. Which one would you put first on your bookshelf? Well, you should put A Tale of Two Ints capital first and then lowercase. Capital letters should have priority over lowercase letters. When a string asks to be compared to another string, it is asking where it is placed lexicographically. You can think of that as alphabetically. The outcome will be an integer. We have to decide what number we would assign to the following comparison. So if the Old Man in ASCII asked to be compared to the Lord of the Files, what number would you return? Whatever number you thought, it should be a positive number. Because the Old Man in ASCII will be put on the shelf after Lord of the Files, sometime after it. It shows up later. You have to plus some spaces to get there. Now, the actual number we will see in a little bit. The thing that we are paying attention to now is that the outcome of the comparison depends on who is asking to be compared. Which book is calling out whom? Which means if the Lord of the Files asked to be compared to Old Man and ASCII, we would get a completely different number, even though they are the same two books being compared. In this case, we would get a negative number because Lord of the Files comes first. Now, what if the Old Man in ASCII asked to be compared to the Old Man in ASCII? That will also evaluate out to an integer. This one is an easy number to figure out what it is. It is the number 0 because it is the same book. They would move 0 spaces away from each other. This is what that compareTo method looks like at the Java API. It will return an int. The name of the method is compareTo. It will accept a string, which is the other string that you want to compare yourself to. Now, we said it will return positive and negative numbers. How it calculates that number is by using this table called the ASCII table. This table assigns a numeric value to all of our symbols and all of our numbers and all of our characters. The ones that we want to pay attention to are our capital letters, where capital A is assigned the value of 65. Our lowercase letters, where lowercase a is assigned the value of 97, and our numerals, where the number 0 is assigned the value of 48. Notice that 0 has the lowest assigned number because if we were alphabetizing, we would alphabetize things that have numbers first. Then we have our capital letters. And then finally, when alphabetizing, we would go by our lowercase letters, which means if we had the string apple asking to be compared to an orange, we would know that this should be a negative number because apple should come first. Apple is saying, hey, compare me to that orange. And we're going to say, you come first, Apple. It's going to be a negative number. It's going to be negative 14, which is how far away capital A is from capital O on the ASCII table. They are 14 characters away. Now, if orange was the one calling out apple, if orange was saying, hey, compare me to that apple, we are going to get a positive number because orange comes later. And we're actually going to get a positive 14 because that is how far away capital O is from capital A on the ASCII table. Now, if orange asked to be compared to orangutan, are we going to get a positive, negative, or zero as our answer? We're actually going to get a negative number. Orange comes first alphabetically. The negative 16 is we are comparing our first difference, which is the E in orange gets compared to the U in orangutan. All of the characters before were a 1-for-1 match. And so this will return the result of the first time that it finds a difference in those two words. Now, if we compared apples to apples, capital A apples to lowercase a apples, capital A comes first. Now, it's not just 26 characters away, which is how many letters are in the alphabet. It's actually 32 characters away. If we looked at our ASCII table, the lowercase letters do not immediately follow the capital letters. Now, if we compared apples to apples and they were the same all the way through character to character, we would get a 0. So the compareTo method will always evaluate out to an int. The string calling the method determines if that number will be positive or negative or 0. This aligns with our essential knowledge that the compareTo method is a method from the string class. That's going to do it for this lesson. You should rate how you feel about that learning objective. Make sure that you hit me up with any questions or concerns that you have regarding these concepts. Join us in our next video and keep programming.